department last 2 years, last 2 springs, actually. So, first of all, I will do some introduction how advanced Field-Map user are we, and in which project at our university we use Field-Map. So, first of all, we have used Field-Map since the third International Field-Map Conference from 2010, so we are quite young user of Field-Map technology. We have actually 3 sets, two full, I would say tough sets, and one we call, we laugh at our department that this set is for ladies, so the stork. It's quite nice when the tough conditions are, but actually we prefer to work with this detailed, this set. And of course, in addition, we have the full software, including inventory analyze and stem analyze. So during those full 5 years, we realized 3 main projects at our department. First project deals with the silviculture planning in forest stands managed by means of complex silviculture system. We mean this Swiss system, improved irregular shorter wood system, and selection system. So during this project we delivered last year with some success to the state forest, and this project within this project we remeasure and establish about 26 control units. We call other control units. I don't know if it's a good term in English. It's directly translation from Polish. And we perform use Field-Map as a tool to support the silviculture planning. So it means we need to collect data at the level of whole stands, so regeneration, where is the flora, but also the single tree elements to be able to build equilibrium curve, for instance, in the selection system. And then we use inventory analyze to produce outputs that we use further in our model that was developed by Staszek at our chair, based on this BDQ USA method. So this is how it looks like. The main idea was that we should shift from clear cutting to more close to nature silvicultural system. This is the example of texture, such a forest. Usually people cannot recognize that something wrong is going on because you work with the small just patches you cut, and large meantime you extract just the single trees. So the regeneration period is quite long, 30, even 40, even you don't define a regeneration period. And one nice, there are many advantages of Field-Map in this case, because mapping it's quite easy, so collecting data at the stamp level are quite easy. And ready shape files we implement to our state forest system that they can simply took to our information system and use as elements, spatial elements, silviculture planning, and then also all the things like diameter distribution, assortments, and so on. So this is quite important during the silviculture planning. So this is first project. The second project that we conducted and we provide the report last year. It was the influence of different management and protection regime on the long-term spatio-temporal dynamic of Białowieża forest. And just for those who are not so familiar with the Białowieża from outside Europe, so here it's Poland between, difficult, so here you have Poland, here it's Russia, here it's Germany, Baltic Sea, and Białowieża forest, it's between the border between Poland and Belarus, and this is quite important. It's divided by 2 main parts: managed part This is this part and the Białowieża National Park with the core area, strict reserve, that was almost never touched by human direct, I would say. So the total area of Białowieża forest, it's 120,000 hectares, but Polish part it's almost 50%. And within this project we remeasure our long-term plots that we have in a strict reserve since 1936. So it was the next almost 80 years of observation. Then we remeasure our 5 long-term plots in the managed part of the Białowieża forest as a this is control, this is the managed plots, and then usually we forgot about this fact that Białowieża was quite intense utilized during between the First and Second World War, and about 30% is covered by so-called secondary growth forest. Almost now the age of these forests are about 90 years old, dominated by birch, hornbeam. So this is actually 3 main type of forest: virgin forest, old growth forest managed by foresters, and then secondary growth forest. So there are 3. But I'm not going to speak about this time. I would say that we also use currently Field-Map. Actually, we are using for any project that Field-Map fit requirements, and as programming scripting give us really huge opportunities. With help members of IFER, we develop our project, and for instance we use quite nice with huge success for testing the new generation of valuable trees. So we have such a huge project, many thousands of seedlings has to be measured. So we use electronic pole, so we automatize the measurements of height, seedlings heights, then diameter at the age of 10, for instance, branch diameters and so on. So everything is automatized by means of Field-Map. But actually, I would like to speak today about the gems of the Białowieża forest, about outstanding trees, monumental trees, large trees. Actually, since a long time, those trees pay attention, many scientists, as it is really one of the best preserved piece of forest in Europe, at least in lowland parts. And here you have the different professors, different papers that gives the numbers about the maximum diameter and height if measured of the trees. However, for instance, this Paczowski, he gave real values. Karpiński, there are just estimated value, the largest tree, so 3 meters of DBH for oak, quite a lot. And what it's also worth to say that those all things, those authors usually works with subsample. They simply go to the forest and what they observed, just they make the notes and that's it. The huge measurement action with recognizing also age was made by Zaremba, one of our university professor, and actually up to 2004 all those scientists worked with subsamples. And then one of our professors during some talk with Zaremba and Spalinsky, they wanted to estimate how many trees do we have in strict reserve of Białowieża forest. Zaremba said, okay, maybe 5,000 trees. Faliński answered maybe 4,000 trees. And in total, all monumental trees in Poland, we have less than 3,000, including solitary tree, excluding strict reserve. So this was not well known, and that's why we employ and started master and bachelor thesis under the supervision of our teams to go through the forest and really with transect to have a look on the trees, to take the position of each tree and at least diameters. And for this we need the minimal threshold, which tree should be included to this dataset pool. Here you have the perimeter, because usually you don't have such a huge caliper, so we measure the perimeter, and this is the threshold, minimal threshold in centimeters. First of all, with spruce and pine we include 1 meter threshold, but it seems to be that it was too much, and then we decrease to 80 centimeters, because it's quite difficult to find such a huge pine and spruce trees. So this is the results. Actually, we finish this year with Staszek. We support a lot this work. Last 2 years we went there with our students, with scientific clubs to finish this huge work. This is the result. You see some white spots, but this is not. Here there are some succession forests, so young forest, and here you have the swamp forest, and here you have the mesotrophic site type. So it means usually the largest tree grows in a eutrophic and wet sites, and that's why there are some still spots, but they were actually checked by me. So this is a picture taken from this part. All the things you have to move by your foot or by bicycle, and then there are just one path that you can go around here. So this is swamp forest without any monumental trees, and this is riparian forest with our students and stork set. And then in a literature, actually, that was published and worldwide available, was publication by Palinsky. And here you have some standard that it's quoted in all of the paper by the different other authors. But if you have a look, it's from 14 years ago. And that's why we wanted to of course, have a look once again on the diameters of those trees, height, and of course at the new biometric parameters like chrome projection area, stem volume, such a biometric parameters, because it is quite important from the modeling point of view. We have a lot of equation for the managed trees, and there are hardly any such a huge trees, and we need to know the diameters, the maximal diameters for such a trees. There are hardly any publication, just one by Hausenauer, but this is rather about the solitary trees, the trees that grows in the open space. And to get to know about the maximum diameter when the trees grows in real forest with the competition, there are hardly any, and that's why we wanted to investigate, and we did this project. So simply we took to Field-Map the pool of all of the trees. We selected the from each tree species the bigger trees based on the DBH. We took all data to Field-Map, then we navigate to those trees, and then we remeasure all of the things by means of Field-Map, traditional like height, diameter, but then we perform chrome projection, vertical as well horizontal, and we measure upper diameter. And this is quite a new thing. This diameter, we use 6-point methods developed by IFER. However, we add some more points, not only 6. We try to at least measure 9 points. This is the actually pilotage study. That's why you are together with Staszek. Normally we work separately, we have pullmans, our colleague serves as a pullmans, and we usually are the operator of the computer, but we need to learn, adjust the methodology to our research. So this is well known for you. Then you have automatically the crown model and surface, whatever. Now the results, in totally we measure 188 trees, but as we wanted to at least produce some allometry function, we add for spruce to have at least 60 trees, some more trees, but I will just focus on this data set as this is quite fresh and not included here. This is the special distribution. The colored is included in the results. This is already excluded. So here you have the maximum DBH. You have oak, macic. This is the gray box indicates the mean values, and this is by minus maximum. So the biggest tree, the largest tree, 2.3 meters. And if you have a look on the birch, it's 1.5 meters differences, and it's difficult to show on pictures how they are monumental, but they really give an impression. So this is lime, 1.7 meters. Then we have height. So by Karpiński was 52. We just meet 48 meters height. There are many trees more than 40 meters. This is the examples of this spruce with 48 meters, 44, and 45 maple. Then we have the crown area. It's quite interesting. According to silvicultural thinning squads, you usually should have 100, 120 oaks, but if you compare such a large trees, so even 15, it's enough to fulfill the place. The lower and most efficient is pine. Then the stem volume, you see this largest oak, 60 cubic meters just stem, so it's really amazing. I compare with our function available for based on the managed forest, so the difference was just 6 meters. So I would say not bad. I expect some more difference. In case of this birch, it was just 0.4 cubic meters, the differences. And now I would like to stress that it was the last time that and very good time to measure those trees, because Białowieża forest is changed a lot. Now the outbreak of spruce is coming, so this is the example of dynamic tree species change on one of our long-term plots. This is the state in 1936. You have spruce, pine, oak, birch, lime, hornbeam, nice forest, mesotrophic site. Then it's change a lot. So you see how invasive hornbeam, there are no pitch, so hornbeam and lime, it's invasive. This is 2001, Staszek was measuring those subplots, and I was measuring in 2011. There are no dead trees, but it wasn't easy to remeasure this plot. So you see how the spruce decayed, and this is now actually all of the spruce in Białowieża forest, really all of the spruce looks like that, and hornbeam it's waiting, and it's replacing. This is the elm 1.3 meters, spruce the 1.4 meters, unfortunately not ready to measure. Some oak 1.8 meters. It's amazing. Around 50 meters you have such oaks, sometimes 10. So this is really nice. Lime 1.7 meters. Trees you have lime, spruce, and maple. Then you have oaks, the row of oaks, and bisons that it's possible to meet. Thank you for your attention.